I wish I knew a bit more about you as an audience. So please tell me who of you is studying somewhere in a university or, I don't know, something like that. Student. Yeah, good. And who is getting paid for doing some IT stuff? Who has a job? Good. So, and who of you is a kind of manager? Managing something. Good. So we have a mixed audience today. Nice. In this presentation, the level of this presentation, I mean, in technical details, is not that high. So I bet specifically managers will find them welcomed and comfort. So let's start. Basically, savings on cloud cost is about optimization, right? Optimization is analytics plus actions. So to optimize, you need to know the data, something about you, something about that you want to optimize, but that's not enough. It's not enough to have a transparency or something, but you should be empowered to make changes. If you are not, like, for instance, using some very, very complex platform service, well, okay, you see clearly that you're paying a lot for it, but you can do much with that. So there are features that are available almost to any cloud, including Servercores, that are simple, which usually comes with some metrics, and which you can use, you can change, you can do a push and see the result. So today we will cover only 4 simple ways to reduce cost in a cloud. Naming for that features are from Servercore Cloud. Sorry, I'm from Servercore. I won't pay a lot of attention to some other providers, obviously. These features are frozen instances, shared cores, Kubernetes with autoscaler enabled, and bare metal instances. Let's start from the, as I've mentioned, there are a lot of different ways, including partnership discounts and refactoring your applications to reduce memory footprint, for instance, but we won't be talking about that today. Yeah. So what frozen instances are? Basically, in AWS or Google Cloud, it's the mixture between your actions, like instance termination in AWS Cloud or instance power off in Google Cloud, and the effect cloud gives you. When you turn it off, you stop paying for CPU and RAM. At Servercore, we started from another approach. So typically, if you turn off your instance, you pay for it, like if it was turned on. But now it's like a fresh release. You can freeze your instance. It's just another action, but it works exactly the same. You stop paying for CPU and RAM, and you continue paying for volumes, IPs, and stuff associated with your instance, which cannot be taken from you, brought back to some shared pool, and given to another customer. With CPU and RAM, we can do that, so you are not paying for it. Yep. What it is suitable for? Mainly for development environments. In some cases, you can freeze remote desktops. If you're working for a large company, you have IT department, multiple departments with just users, and you launch virtual machines with RDP access or some VDI in a cloud. Probably those teams won't be using them in the end of the week, right? And after the workday, you can freeze those machines and save. At Servercore Cloud, it's just a basic calculation. You know, you can do the same for your project or for your idea. If 4 virtual machines, like here, with 4 CPUs, 8 gigabytes of RAM, and 50 gigabytes of SSD, is not frozen. Yeah, it works always on. It will cost almost $250 per month. But if you are able to freeze it, and for it to work only like 8 hours a day, the price reduction will be Surprisingly, almost 30%. Yeah, even more. Good. So there is a quick demo how it works from the control panel. It's super easy. I was like asking myself, should I make a demo of this functionality? Probably, yeah. Let's see how it works. I will make it full screen and I will pause to, yeah, give me a second. Nope. Nope. Yeah. So this instance freeze is available straight from the instance list. You can just click on those three dots, confirm the freeze, and wait around, I guess, 10 seconds. This can also be done from instance details list. So if you click on the instance name, you can find a button for more quick access. Again, the same, you just confirm the freeze, instance becomes frozen, and in the list of servers, you see all of them in a state frozen. Yeah, you can power them on right using the same control elements, so shouldn't be problem. Note that some instances are labeled with freezable tag. This is something you can done just for your for the sake of clarity for you, for your team, but this can be used in automation. And the next slide will show you how the automation can be used, because in situations when you have like 10, 20, 30 instances, clicking all those buttons, it's not something your mother had given you birth for. Yeah. So you can do a very quick automation. So I used to be a software developer 5 years ago. So now I only write in scripts, very basic scripts, CLI something. So yeah, but I love it. And I love this flexibility and the easiness it works. So yeah, Servercore Cloud comes with an OpenStack API. OpenStack is a open source framework for building clouds. There are more than 500 companies that are building private clouds using OpenStack. There are also some like I could name like 3 companies that are using OpenStack for building public cloud, like AWS and Google, but built on OpenStack. So it's like a standard. Yeah. Even VMware has OpenStack API. So you can work with VMware using control panel, and you can also use VMware OpenStack API compatibility something. So, and when working with OpenStack, you can use OpenStack CLI. It's a Python application which utilizes Python libraries to work with APIs. So yeah, it's easy to use. Here I launch a command to list the servers. It gives me all servers I have in that project. Yeah, I don't need all those servers. Basically, I need only those that are labeled with tag freezable. Yeah, I filter using that tag. Yeah, I have only 2 now. And when I have this list of 2 instances, I can ask this CLI to give me only IDs. I don't need all that stuff, all the dashes and everything. So I say, please, only ID and in value format with no extra wrapping. And then when it gives me those 2 IDs, I just pass them to xargs utility. It's basic Linux stuff. And this xargs calls in parallel 2 instances of OpenStack server shelf command. Yeah, that's how it looks like. So this screencast was a bit longer than the previous one. But yeah, so those IDs are being passed to OpenStack server shelf. This command is getting executed. With command -p2, you can control the parallelism. Doesn't really matter here, but yeah. And when you call for a list of server one more time, you see that those servers we've gotten are now shelved offloaded. Shelved offloaded is a kind of technical status for those frozen instances. Yeah. That's it. Basically, you can use this one-liner inside a script, which is run inside a cron tab or some other schedule you like. Of course, it's not enough. Probably you should think about whether this command returned what you were expecting, but the idea is basic. Basic idea is simple. Oops, sorry. Yep. Yeah. Another feature, which is available in, as I've said, in many clouds, is shared cores. In AWS, to get a shared core, you launch an instance from like T-Series instance line or something. In Google Cloud, they have E-Series. In other clouds, they have something like that. So it's not sometimes clearly visible that you're using shared core. But if you look into details, you will find that T5 something will give you like 40% core, blah, 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 with lots of different complicated stuff like CPU credits. At Servercore, we do things simpler. We just write the percentage in the instance type name, so it's easy to understand. And we are not using CPU credits. If nobody's using the core, you have 100%. So things are going easier. Again, what it can be used for is development environments. So basically, when you're testing something, you don't need 100% core, almost never. You will be fine with 10% core. You will save a lot. If you're launching microservices and you are not using and your services are really micro, you will benefit from it as well. You can launch small instances with very low memory footprint and with a shared core. Yep. Saving can be huge depending on the size. Only CPU cores are getting discounted here, so you pay regular price for RAM, regular price for SSDs. So depending on proportions, you have some amount saved. Again, the same example I've just calculated here for 50% shared cores and 20. Let's see how things work. Yeah. As I've said, shared core is just a new for Servercore Kenya, but it's just an instance type. And how to spot if one of your servers can be migrated to a shared core? Yeah, it's a place where transparency comes into play. Almost in any cloud, you have an access to utilization reports. Yeah. In some clouds, in order to do that, you have to connect some service, go to external dashboard, look for numbers there. Again, here we have a way simpler solution, which works almost the same. Probably somehow one day we will transform it, but now these measures are just accessible in server details page. So how to spot an instance that can be resized? You just look at CPU utilization. Mainly, it's the main factor. If you see that it is limited almost all the time at the low numbers, like here on the screenshot, it's limited to 26, 25%, you can you can be sure that you can migrate it. You can resize it. And here you will have a choice to just reduce the number of cores inside the instance, but this will inflict probably some architectural changes inside your server. So some applications probably will have to be reconfigured. For instance, if you're having PostgreSQL server and you've configured it to use 4 cores, resizing to 2 will inflict necessity to reconfigure Postgres, stuff like that. But there is a simpler solution. You can avoid doing all that. You just resize your server to a shared core flavor, keeping the same 4 cores, 8 gigabytes of RAM I have in this example. Yeah, there is a new tab here, shared. You can pick here. Yeah, I haven't shown that, but you have 10%, 20, 50 here. You choose a new configuration, and it's applied in like Less than a minute, typically less than a minute. Of course, server boot will take some time as well, but it's a quick operation. That's it. And again, if you have some number of servers, what? You might benefit from automation. So guys, for some reason, sometimes those slides work not as intended. I'm sorry. Automation is also possible, of course, using the same CLI I'm showing here. We have also compatibility with Terraform, so the same operations can be done through Terraform if you like. Here I'm showing the server list. After that, I'm asking Cloud to give me a list of flavors with percentage over core. So PRC here is not for People Republic of China, but from percent. When I'm grabbing for it, I have a number of options available. Yeah. And here I'm just doing the same. I'm picking a configuration which has the same architecture. Yeah, 4 cores, 8 GB of RAM. And I'm issuing a command OpenStack server resize. I'm giving it a server UUID and asking it to use a new flavor instead of the previous one. Yeah. And after a while, I see in the server list that this virtual machine was migrated to a new flavor. I asked it. Good, easy. So this automation can be really helpful when you don't have access to a control panel or don't want to use it, or you have lots of servers to resize, So another thing which is different from previous two is Kubernetes. Many of you have at least heard about that. Lots of you are using it. And de facto, it's a standard for any system which needs to be agile and automated. So we've been using Kubernetes. We've been providing it as a managed service for like 3+ years, I guess. Yeah. And at the beginning, we didn't have such feature like Kubernetes autoscaler. Our customers had to install autoscaler inside the clusters and do all that integration stuff. Starting like probably a year and a half, we have Kubernetes autoscaler enabled by default, and all you need to do is just tick a mark while launching a cluster. What it is suitable for? Of course, web applications. Web applications with variable input. We have a customer that have a Kubernetes cluster running at 3 nodes almost all the time, except rush hours for their services. And those rush hours started at like 10 in the morning, and they continue to like 4 in the evening. And during that period of time, their cluster runs at 12 nodes. And to achieve that flexibility, they're doing nothing, basically. So of course, they've invested a lot of time into setting things up, making sure that the application is scalable and all that, But after that, they're chilling, and the cluster is getting scaled up and scaled down. I know we have customers, but I cannot give you a more precise example that are using Kubernetes with autoscaler for batch processing. So they have some jobs arrived to their S3 containers. Their Kubernetes cluster getting notified that there is some job to be done, and that it should be done in like an hour or so. The cluster is getting upscaled because those 3-5 nodes they have normally are getting loaded too high. So the cluster is scaled. When the job is done, so there is no more work to do, it is getting downscaled. And those periods of time between checks is like 10 seconds or something. So it provides you with very great granularity. Of course, this functionality is enabled in any cloud provider which is matured enough. which have a solution for managed Kubernetes. And if you are building a Kubernetes yourself on a self-hosted infrastructure on top of a virtual machine, you can just enable it. Yeah. Again, here is an example of a cost I've calculated. For the example I've told you about. So if the cluster is full size, 100% of the time you pay almost $500 for a cluster of 6 nodes, 4 CPUs, 8 GB of RAM each. Yep. If you are enabling an autoscaler, and it will allow you to shrink the consumption to be full size only 30% of the time, this count will be as following. I have a quick demo. Sorry, no, it's not quick. It's not quick because, oh, it's Kubernetes. At least we are not using kubectl today. But I will show you that while creating a cluster, all you need to do to enable this autoscaling mechanism is to, first we are choosing a configuration. Yeah, that's it. So autoscaler is a thing that is attached to so-called node group. Node group is a Kubernetes abstraction on top of a cloud server group. So when you are creating a node group, you are choosing this atomic configuration. This group will consist of, you are choosing amount of nodes on start, and you are setting up the minimum and maximum amount you want to use here. Yeah. When you launch a cluster, it will start and it will show you a picture like that. When the cluster will see that CPUs on those nodes is getting loaded, it will automatically launch new nodes of that size using the same base image and everything to fit the cluster in between 3 and 6 nodes. Let's see how things work when this load we are getting prepared to arrive. You can spot the difference, for instance, in a servers page. So when launching Kubernetes in Servercore Cloud, you have access to those working nodes. So in some clouds, everything is getting hidden inside some so-called project available only to a provider, but you see only something. At Servercore, as I've mentioned today, things are simple. So if a Kubernetes cluster scales, you see all its nodes inside a server's page, like if you were launching them yourself. Yeah. So if we move from cluster page to server page, we see those nodes, 2 nodes, like servers. And when the load arrives, you will see that new nodes are added. They're passing through different stages, like build, block device mapping, and other spawning finally. Yeah, they're getting IP addresses. And in a few moments, you see them all active, ready to accept new traffic. I don't have a demo for enabling autoscaler in a cluster that already exists, but it's also possible. Yep. That's it. The last way to reduce cloud costs is a bit different in that line, because it's, let's say, previous ways you are working with cloud objects. You were stopping servers, stopping paying for them. You were resizing them to a less performant backend. Yeah. You were using advanced technologies in Kubernetes. But there is another approach, which is not usually possible in all clouds, but it's possible with some. At least with Servercore and Scaleway and probably some others. It's a migration of a cloud something to a bare metal something. Typically, for instance, in AWS, you have an access to C5 metal instances. They will give you like I don't remember exactly, like 96 vCPUs, something. And it's a pure equivalent to a virtual machine of the same size. So like C5.x large something will give you the same amount of resources at the same price. So at AWS, you won't have a price benefit. They just charge you the same amount of money, saying, okay, you don't want a hypervisor, here's bare metal, work with it. At Scaleway, it's I don't know how you are familiar with those providers. Well, it's quite popular in Europe. They have a elastic metal service. They call it that way. And at Scaleway, you have those bare metal servers slightly cheaper than equivalent in a cloud. So you have the same amount of cores, RAM, and something at a reduced price. At Servercore, the price drop is more visible. Why is that? Our Servercore offering, our bare metal offering is not that developed as with major providers. For instance, in AWS, you will be able to connect network drives using some advanced firewalls and all that, everything cloud with C5 metal available. At Servercore, our bare metal is way simpler. Again, you have a nicely built, thoroughly tested, everything's perfectly working bare metal server, and that's all. That's all you have. You have very well built with good network, but that's it. And that's why it's cheaper in many ways. How can you use that? I'm here not describing situations when you just know that you need to have a bare metal, because there are lots of situations when you, for instance, need to plug something into a physical machine. You have a USB token, right? Or you have necessity for specific physical device, like specific, let's say CPU. You're developing something using C, and you need to optimize for specific hardware. Well, bare metal servers is the way to go. But in many situations, you have something like stabilized or legacy services, which are not experiencing load amplitudes. It works the same all the time, every day. You have the same and the same and the same. You're just not using cloud capabilities like scaling, Kubernetes. You're not resizing volumes. You're not doing anything with the servers, but you need it. And in situations like that, you will benefit from migrating them to bare metal something, because bare metal is cheaper on a long run when you don't use all that flexibility. And sometimes you have homegrown PaaS services. That's how we call them. Something you have built. Sometimes it's just monolithic application, huge, with database not managed, but database, API, and backups all in one place. And you're not willing to do anything with that. Again, here, you won't be using 10 virtual machines, right? In the cloud, you'll be using a huge virtual machine and with no flexibility. Again, here is the way to save some cost, just to migrate it to a bare metal server. Here's an example. Let's say you have some amount of virtual machine in the cloud, like 32 cores in some and all those other parameters. If it's possible for you to compress everything in a 3 bare metal servers, if there are no limitations for you, yeah, sorry, I forgot to 3. It's not 33 here, it's just three bare metal servers of this configuration. You will have price reduction of almost 30%, which is good. You will also have lots of storage you probably won't be needing, because that was we're using in the cloud. But yeah, here how it works with bare metal. Sometimes you have excessive amount of resources. In terms of migrating from cloud to bare metal, it's crucial to have a network connectivity between cloud and bare metal, because otherwise you will have to transfer the data through the internet with all the limitations. Sometimes you won't be able to do that because of security restrictions. Who will migrate database through the internet? Complicated. At Servercore, you have a router that connects bare metal with cloud. And in the next screencast, I will show you how to do that, because it's something we are proud of. That router is a really good thing. So this screencast will be the longest. Keep up. So we start with a cloud platform, having some virtual machines with our legacy something. After that, we go to servers and colocation. We choose Nairobi. And after that, we pick up a configuration for our bare metal server. Let's say we've picked up this configuration. We choose it to be paid monthly. And we pay now and confirm. It will take around, I guess, 20 minutes or so to set up a server. It's way longer than with virtual machine, but more things are getting installed and configured. While it's being done, we can go straight to network services and create that router. The router is named global, which means that you can use it to connect different parts of Servercore Cloud. It's not something that is publicly accessible. So it's not a global router in terms of internet connectivity. It's global because it connects different parts of distant architecture inside the cloud. It can connect cloud in different regions. It can connect bare metal with cloud inside one region and vice versa. So while creating the router, I just give it a name, a subnet name, and I'm picking up the networking schema I'll be using later. Network creation takes less than a minute, so it's what we are doing that on a backend. We are going to network equipment and we are configuring it. So it's like physical routers being configured through an API. After we have created a bare metal network connected to the router, we have gone here to a cloud side with those legacy applications. And here we are not creating any new networks. We're just connecting that network those services have been using for a year to that newly created router. It again takes some time, but it's not long. Again, this network is being configured on this routing is being configured on a number of physical network devices. After it's done, you see that this network is connected to a global router. While you were doing all this, that bare metal server probably have been set up, and you can check that everything works through a network map. It's static. It does not provide you some latency checks or something. It just visualizes stuff. If the architecture is a bit more complex than pictured here, it makes some sense. That's it. Yeah. So I'm finishing now here. And the takeaways here is that optimization in the cloud comes through analysis. Right? You need to have some data, some knowledge in order to be able to think about changes and to make them. And what it makes possible to not think too much before the launch, actually. So the cloud flexibility allows you to postpone that thoughts for later. When you, for some reason, have to save on cloud, you can do that through that knowledge you get from graphs, from utilization. And what's more important, you are able to make changes. So when launching something, think about that in advance. So we are now expanding here in Kenya, and we are working with customers which are migrating from AWS, Google Cloud. And when they migrate from something truly advanced, like data streaming, something built with lots of gateways, it's truly a challenge to change something when you have already built something complex, because there is not much room for an optimization. So if you plan for future, think, what if someday we will have to save on cloud costs. And just at least have a plan. Test that you will have access to graphs, that you will be able to make changes. And that's it for today. Thank you.